Hello everyone, I welcome you all to my YouTube channel. In the upcoming lectures, we will be discussing about external lightning protection system. We will discuss about how to design this system, what all standards we have to follow, and what all parameters we require in order to design this system. External lightning protection system, it mainly comprises of three items. The first one is the air termination system, second being your down conductor system, and the third being your earthing termination system. So if you look, let us suppose this is your structure and this is your ground. So this is your air terminal rod or air termination system. Then this one is your down conductor system, which is just connected to the wall in purple color. And then in green is your earthing system, which is your lightning rods or your earthing rods. We will understand why lightning and earthing has to be combined together. However, this has already been explained by me in my lecture 8 of earthing bonding series, that all the earthing system, lightning system, everything shall be combined together. So in this lecture, our main focus will be on understanding on the air termination system. In this and the upcoming two lectures, we'll be focusing mainly on the air termination system. What does it do? Whatever happens, let us suppose there is a lightning strike. So if this air termination system was not there, let us suppose it is not there, this lightning strike will happen directly on the structure and it can destroy your structure. Within this structure, there can be some equipments which are very important for you and they can get damaged. So to avoid any damage, I am giving in simple words only here. To avoid any damage, we provide this structure on the top, which is air termination, and it will take the lightning strike, it will absorb, and then this lightning will go through these down conductors and follow this path, which is the lowest impedance path, not the lowest resistance but the lowest impedance, because lightning phenomena is a very high frequency phenomena. We always talk about low resistance, but it will involve a very high amount of inductance, which is omega times L, which is a function of frequency. So it will follow the low impedance path and go into the earth. So it cannot be always straight. We will understand this all. Now, lightning protection system can be of two types. The first one is the isolated, the second one is the non-isolated type. In case of isolated, the structure is typically made up of any combustible material or there is a risk of explosion there. So that means you have to isolate the complete LPS. So our lightning protection system here involves air termination, down conductors and earthing. This shall all be separate from this structure which we have drawn, completely isolated. Whereas in case of non-isolated, there is no such risk, and typically in railways you will see that most of the structure are non-isolated. In many cases you will also see that these down conductors which are coming are also not available. They are basically connected, these air terminal rod are directly connected to the reinforcements, and there are some typical measures we need to take. Everything will be covered in these upcoming lectures. Now, talking about only air termination system here, they can be of many types. The first one is only having rods on the top connected together. The second one can be with the catenary wire, as you can see here. This is also interesting to see that it is not connected to the structure, so it is an isolated form as we were discussing above. And the third one can be a mesh. There can be a fourth one which can be mesh plus air terminal rod. There can be many types. There can be a combination of all these three. But these are the typical examples. Normally this shall be at the edge. There will be a question that why it is not shown at the edge. This is an image which I have taken. But this is just an example. We will understand this all. Now talking about air termination system, you see these rods, these mesh and all everything. How to decide what number of rods we require, because whenever you go to your project manager, he will always ask for low cost solutions, and you also have to design a low cost solution, but it shall be safe. So how to decide whether you require one number of rod or only at the edges I can provide and satisfy myself? or do we need to provide in these middle also these rods? What is the height of these rods that I have to provide? And all this is explained by IEC 62305-3. This is the mother of all standards, and 62305 is the series for lightning protection. So -3 is this standard which gives us how to size this air termination system, and it gives us 3 methodologies. The first one being the rolling sphere, which is the most popular. Second is the protection angle, which is also very popular, and third is the mesh, which is a bit less popular. But IEC does not say that 1 is more preferred, 2 is less, and 3 is less. This is not said by this IEC. You can choose any one of these 3 methodologies. However, rolling sphere is widely used because it is the more accurate one compared to the protection angle and mesh. Protection angle is basically a mathematical simplification of this method of rolling sphere. We will understand first in this lecture the basic concept behind these 2 methodologies. We will not discuss about the third. In the next lecture, we will understand the math behind protection angle method, and in the third one we will understand the math behind the rolling sphere method. This is very important because by listening and understanding these, you will not require any kind of software, not even AutoCAD, to design your system. Only following these steps you will be able to design everything related to external lightning air termination system. So let us first understand about what is rolling sphere and how it has evolved. So let us suppose there is one structure and it is on the ground, and there are some clouds, and there is some positive charge developed on the top of the clouds due to the ice crystals, and below due to waterlets it is negative. Now this is a typical phenomena which you will study in many other places, but it can be reversed. Some people say opposite, but our intention is only to understand the topic and not to talk about how lightning is occurred. So we will not focus on that in this lecture. So let us suppose there are negative charges here, and due to this negative charge it will induce some positive charge and it will attract these positive charge from the earth surface in order to ionize this. So now there is a very high amount of electric field between these two surfaces, that is the cloud base and the earth surface. So this negative will try to come down and follow and combine, and this will be seen as a lightning strike. A flow of current then flows. So when this comes down, it comes down in a scattered way. It is called the ladders or the leaders. These are the downward leaders, and these are typically of 50 meter length, but it can be of variable length, but just assuming here, and it will carry this negative charge, and this will start coming when there is a huge amount of electric field now between the cloud and the earth, and air starts to get ionized. So in that case there has been a breakdown and this negative charge starts flowing. Once it reaches this point, and now it is about to attack the highest equipment which he is able to see, because it will not have to go to the ground, which is a longer distance. So it will see this point, and it will not strike only on the highest point, but it will check which point has the highest electric field intensity. So there must be a accumulation of positive charge, and there only it will attract. So that is why you can see that not always the taller the structure, the lightning will strike only on that. Sometimes it strikes on the, suppose this is your structure, it is not only it is striking here, it can strike on the sides also. There is something called side flashover, so it can strike on the sides also. It is because of this reason that there will be a high amount of electric field intensity at those edges or those points which are very sharp. Now let us suppose this is the point where it is about to strike. So it can, now it has to take the last step, which is also the return stroke. Sometimes the positive charge goes and combines with the negative, making it a return stroke. But let us suppose this is the last step, and this last step is called your striking distance. This is your striking distance. And to evaluate this, we can make a sphere, because lightning can strike in all the directions. So that is why we have to assume it as a sphere. Now you can say that it will not go on the top because it is going on bottom, you are right, but we assume this as a sphere here, and it can strike in this point or this point, any other point here, but it will not strike where? It will not strike within this point. Any point here within this is protected. So you can see that rolling sphere, when you provide this sphere, this region is the one which is getting protected, which I have drawn in red color. Now, being this the striking distance, this will be your radius of the sphere. And what shall be the radius of the sphere? This is a very big question. Now, this radius is determined by the class of protection, which is basically the class of LPS, and this is governed by a standard IEC 62305-2 based on the risk assessment. So we perform some risk assessment study based on the amount of lightning strikes happening in the year, the Charonic level and everything, and then we find that okay, there is class 1, class 2, class 3 and class 4. There are 4 types. If it is class 1, then your radius sphere is 20 meters, class 2 it is 30, class 3 it is 45 and class 4 it is 60. This value is given in IEC 62305-3, which we will see in this lecture below. Now we understood that there is a sphere, it can strike. Now cloud is not necessarily here, cloud can be here also, cloud can be here also, it can strike from anywhere, wherever it wants. So that is why we have to now roll this sphere. So we roll this sphere on each side and check which all point have to be protected. So wherever this rolling sphere is touching your equipment, that means your equipment is in danger. So nearly all the points it is touching except for this red area here, and the last sphere it can be here. I have drawn the sphere of different radius, I am sorry for it, but just to make you understand, these areas are only protected, else all this area, all these points which I am now drawing in red are affected, and they have to be provided with the lightning protection or the air termination system in order to avoid any destruction of the structure. So now this is a sphere and it is rolling, that's why it's called rolling sphere. You know now the radius, and that is how you evaluate your structure. So suppose I draw a simple structure here, and this is the rod on the top. So you will draw a surface sphere. So this sphere will be there on the top of the 2 rods, it will not strike anything from the top. Then we will check from the side by rolling this, and we will see that oh okay, so there is no side strike here and there is no side strike here. So all the things are getting protected by providing these 4 rods on the top, 2 here. So if you see the plan, top view, so here are your 4 rods, and here will be on the top your sphere. This we will understand in the next lecture, just giving you an idea that this area is now protected by this area is now protected, this area is getting protected. So everything within this area is all protected by this sphere. Now we will understand a basic idea of protection angle. It is nothing, this protection angle method is basically a mathematical simplification of rolling sphere method. So this is your rod, this is your vertical rod, and this is your sphere. So the sphere is protecting this area, as you have seen already. This area is protected by the sphere. Now I will just erase this. Now what this rod has to offer, this rod will also offer something, So we have to draw this line. So we have to choose for drawing this line a certain angle. This angle is called protection angle. This angle is alpha, and this alpha is the protection angle. Now you can see that due to this vertical rod which is in black, it is providing a protection in this region. All this region is getting protected. So what is happening? Rolling sphere was protecting from this green part. It is protecting here. So this extra part which is here, now I will highlight in this purple. This extra part is protected now by protection angle. So if I just remove this, just to simplify. So now you see what is the extra part being protected. It is this part which protection angle is protecting extra compared to the rolling sphere. So this part is called overestimated part. Overestimated part. And what is the underestimate? There is an underestimated part also. So which we can draw in a different color. So rolling sphere is protecting this part. As you can see, it is below this green line. So this part is getting protected, whereas protection angle is not able to protect that part. So this part is called the underestimated part. So protection angle offers better protection on the top, not a better protection but a simplification on the top, whereas in bottom it is unable to protect. But in actual, if you have chosen the rolling sphere, you would have found this protection. So let us suppose this area by orange is A1 and this area is A2. So how to choose this angle? You have to choose that A1 shall such that A1 is equal to A2. So it is not that alpha is always 45 degrees. Please note that this is incorrect statement. Alpha depends upon when this area 1 is equal to area 2, and it will keep on changing based on the length. So as the length of this or the height of this rod keeps on changing, there will be different angles. Also, if the radius of this sphere keeps on changing. So suppose I draw a radius of very high like this, so this angle will be different. And if case the rod is different, this rod length is different, it will be different. So it is varying on H as well as R both. So this is a very tough situation. Who said that protection angle is very simple? Yes, now this IEC said that okay, in order to avoid you performing this calculation, I will do, and I will provide you this table. This table I have provided you for, this is said by IEC that we are giving you this table with the class so that you know the radius, and this figure which we are showing, that is figure 1 of IEC 62305-3, which simplifies everything. Using this you can calculate the protection angle. So let us suppose you have chosen class 1 or class 2 or class 3 or class 4 based on your risk assessment study performed as per IEC 62305-2. So let us suppose you choose class 2. So for a 10 meter height, class 2 is providing 54 degree. Class 1 is providing 45 degree. So you see, not always 45 degree is the value. In case your risk assessment says it is class 2, then you can go for 54. Now suppose your height is 20 meters, then again the angle cannot be 45 degree. In case of class 1, it will become 22 degree. Sorry. This will become 22 degree, and in case of class 2 it will become somewhere around 38-39 degree. Class 3 it will be something separate, you can see 48. Similarly class 4 it will be something around 54 degree. So it depends on H as well as the radius, which is that is class 1, class 2, class 3 or class 4. So using this you can evaluate your protection angle method, and it is very helpful. So the limitation behind protection angle is that it is not valid for any distance beyond this point. So in case of class 1, you cannot apply more than 20 degree a protection angle. In case of class 2, not after 30 meters high. In case of this, not after 45 meters. In case of class 4, after 60 meters, you cannot apply this method. Here it is mentioned in the note. This is not applicable. In that case, you have to go for rolling sphere or mesh method only. Typically, we go for rolling sphere in this case. So sometimes there is a design for GSMR towers or for any other communication towers, CCTV poles or anything. You can use these protection angles. Just check the height of this and also the class. Now, in this lecture, we have understood how to basically what is the concept of rolling sphere, what is the concept of protection angle, and now in the next lecture we will be understanding how to solve, what mistakes we make solving protection angle, and then how to rectify it without using any AutoCAD or any other software, basically simple trigonometry. And then we will understand rolling sphere method, how to evaluate it and all, basically using a simple equation of circle, and that's it, and coordinate geometry. So I hope you enjoyed this lecture, and God bless you all.